So yes, thank you, Rusty. Thanks, Steve and Elaine, for inviting me here to talk about something I'm passionate about, which is fish. Um, and so I think I'll start, I guess it's the big play button. I'll start out with the obvious. Fish need water. But the water they need depends on the timing of the water is important, the duration of the water is important, and the magnitude of the water is important in a fish's life. So it's critically important that we understand the life history of a fish so that we can develop these conservation strategies aimed at water use and fish conservation. One of these life history stages and that's important to native fish is movement. So if a fish can move from point A to point B, it allows a fish to seek refuge from drying conditions. It allows a fish to seek access to feeding areas as well as reproductive areas. Wait a minute, didn't I just say fish need water? So does this look like critical fish habitat to anybody? I don't think so. But what about now? So this is Cottonwood Creek over a tributary to the Gunnison River. And in the springtime, in March and April, flannelmouth suckers and bluehead suckers, which are two native fishes, run up there by the thousands. And they spawn in this tributary. By mid to late May and into June, it essentially dries up to what I just showed you. Essentially, these suckers, the reason they're able to utilize this habitat is because, one, they have connectivity to it, they can get there, and two, they lay their eggs over this clean cobble, and the larval fish, the eggs hatch out in just like 5 to 6 days. And so the natural life history of these fish is those larval fish hatch out, they drift with the water, and they end up back in the Gunnison River. So it doesn't really matter if it dries up by July. They've been able to fulfill a very important part of their life history. So that brings me to the point of how do we balance fish management and water use at the same time? And I think a really good way to do that is through fish passage projects, so allowing that connectivity to happen. This is a classic water diversion on McElmo Creek. There are lots of examples around the basin, San Juan Basin, across Colorado, frankly. Culvert barriers in Cherry Creek, barriers to fish movement, including the Weber diversion on the Mancos. I'm not signaling anybody out here, I hope. And then a Florida canal diversion certainly acts as a fish passage barrier. So let's step back and talk about the life history of these fish just a little bit. So this is a native bluehead sucker. Photo was taken in the Animas River. They're common there. And they have a number of life history attributes, including where they feed in a river. They need to access the shallow riffle areas because they have this scraper that scrapes algae off the rocks in the river to feed. And they certainly can seek refuge in a pool to survive, but that's not optimal. And they certainly make long distance movements to spawn, as we just illustrated in that last slide. Round-tailed chub is the second of the three, quote-unquote, three species, these large river fishes that are found in the tributaries of the San Juan and across the Colorado River Basin. Round-tailed chubs occupy the larger tributaries in the San Juan Basin. They like pools with woody log jams and overhead cover. They feed on insects just like a trout do, and in fact, you can catch them with a fly rod. They also will occupy these lower reaches of these rivers and make long-scale movements as well. So, and then lastly, this is the flannelmouth sucker. We started calling him the salmon of the suckers. And it sounds kind of crazy, but they're a unique fish in terms of they're endemic to the Colorado River Basin, meaning they're found nowhere else but the Colorado River Basin. They have these fleshy lips, so they make their livings in pools and the runs in a river system, so they can feed on the softer sediments in the river to obtain algae and invertebrates. They spawn early in the spring as flows start to ramp up. So they're on the move right now. And they make these long distance spawning migrations that I alluded to with the moniker, the salmon of the suckers. And I want to illustrate that very quickly with the movements of one individual sucker out of the Colorado and up into the Dolores. And the reason we can track these movements is because of the development of these pit tag arrays. So if anybody here has a pet that they've chipped, that's a pit tag. That's a passive integrated transponder tag. And all you have to do is wave an antenna over that. It beeps, it identifies your pet. This is the same thing. We actually capture fish in the Dolores in this instance, tag them along with a lot of different other agencies. And if they swim over this antenna, which I just highlighted with that tan, and that antenna is what's floating here, and I guess it'd be to your left, the photo there. We have to anchor that to the bottom of the river. So once a fish swims over it, pings it, uploads it, and we can gather a lot of information about movement with these fishes. So in this particular instance, this flannelmouth sucker was tagged by the Fish and Wildlife Service in 2011 in the Green River. It made its way all the way up 264 miles to Disappointment Creek, where this array is on the Dolores River. In the subsequent years, the Fish and Wildlife Service put another pit tag array down by the Colorado Dolores confluence, and we detected that fish again in, I think it was March of 2016. There we go. And then that fish, in just a month, made its way all the way up to the Disappointment, 130 miles upstream in a month to the array. So, you know, this is a journey of over 504 miles, probably double, triple, quadruple that in the lifespan of this fish. One thing to understand about these Colorado native fishes is they live a long time. They live 30, 40 years. So the conditions don't always have to be great on a single year for the persistence of these fish. So I think that's why connectivity is really important to these fishes. This is just a map of the San Juan River Basin, and you can see with the red dots on this map, those are complete fish passage blockage, things like dams and irrigation diversions. The yellow triangles are what are unknown. These are things like road culverts, irrigation diversions that we don't know if fish can pass or not. And then the green squares are partial blockages. Fish can pass under certain circumstances. But you can see a lot of dots on this map, can't you? There's a lot of room to work on connectivity in the San Juan Basin. But I do want to highlight, as I did in that last slide, if you look on the Dolores River, you've got 185 miles of unfettered habitat, essentially, for these three species to roam. And that doesn't include the San Miguel or the connectivity to the Colorado River Basin. So we're finding that connectivity to different habitats is really important to these fishes. So what can we do? Well, there's fortunately a lot of things we can do. This is a CCI diversion on the San Miguel River. And one technique to create fish passage is what's called a constructed riffle. So it's a series of rock veins that span the channel, interspersed with rubble in between to slowly and gradually move that elevation of the stream up to the lip of that diversion. This doesn't injure the water diverters' right to divert water or ability to divert water. In fact, many times these structures can be less maintenance for the diverter. Another common fish passage project, especially on the Front Range, are these fishways. This is one that allows fish, again, access over a diversion barrier. So these are highly engineered structures, and they work. And then commonly around here is this design, this step pool design. So here's one on the Mancos River, where if we look at it kind of from a top plan view, it passes water, sediment, debris efficiently. It actually has a sediment sluice that when the diversion is turned off and it'll fill up with sediment, you can sluice the water out of there in the springtime, open it up. And it actually has the benefit of enhancing habitat for fishes with pools. and is passable under most conditions. I just went on a rant about connectivity may be the best for fishes, but it depends on where you are. So with the conservation of native cutthroat trout, really in this situation, fences make good neighbors. So in this situation, we actually construct barriers to non-native fishes below, and we reclaim habitat above for the native cutthroat trout because they didn't evolve with any other trout. And we have a lot more options when it comes to managing this cold water native fish. So in summary, fish can move with passage. They can move to better foraging and spawning habitats. They can find refuge from temperature, debris flows, drying. Irrigators can gain a reliable, low-maintenance diversion that passes sediment, and recreational boaters can pass safely over some of these diversion structures that were impassable before. So not all barriers to fish passage are harmful in the case of the cutthroat trout management. The cost is high, but it's typically shared and paid through by grant funding. And that funding actually looks pretty good. With the passage of the Infrastructure and Investment and Jobs Act, I think there's something like $1 billion nationwide to address fish passage projects. And there are a number of other grant opportunities potentially in the works. So I'll save questions for later, but I appreciate the opportunity to talk a little bit about our native fishes and the issue of connectivity and water use. Thank you.